Thanks, Ron. Yeah, welcome. So today I'm going to be talking about DevOps tools on Azure. And I've got a pretty tight agenda. I've got some demos and some other things. And we'll try something at the end too, which we'll see what happens. What is DevOps? I'm going to cover that. And we're going to talk about people, process, and products, which is actually part of the answer for DevOps. And then I'm going to show you a demo of DevOps in action. What's going to happen is going to make a change on my local repo. It's going to be posted to GitHub, and that's going to generate a build and a release out to an Azure web app, which basically runs a software as a service platform for you. And we might have audience participation. We'll see towards the end, depending on how much time we have. I've got an idea for something we can try out, but we'll do that later. I'm sure Ron's thrilled that I'm going to try something out that we haven't tried before, but it works with Zoom, apparently. You can do a show of hands and we can do a little vote. But
we got polls. It's all good. You know,
okay, cool.
I'm a big fan of doing live demos when we do our in-person events, so it shouldn't be anything different.
Sure. Yep. Cool. All right.
By the way, there is, you know what, one individual, just to give you a quick question, came up from Doug about, and I'm not directly familiar with what WLS2 stands for.
WSL2, it's a little, it not necessarily pertains to DevOps, but WSL2, Windows Subsystem for Linux.
Okay, got
it. So it's a way that you run Linux on Windows. And the reason why it's called Windows Subsystem for Linux, which sounds like a bit of an awkward term to me anyway, is because the original command prompt is called Windows Subsystem. So just a little bit of trivia there.
All right. Well, one of the questions was, and I'm sure, Doug, we're going to touch on this indirectly, we can get more information directly, is I am sure that there are ways as part of the development process to move workloads from Windows to Azure, be it Windows on-prem to Azure in the cloud. And if it's not covered by Brian's talk, you can email me directly and we will make sure that that gets answered separately based on your specific use case.
I'm actually going to literally show that in a demo. I'm going to change something on my local machine. It's going to go through GitHub. It's going to be released out to Azure. So I'll show how you do that.
Okay, great. All right, all yours. I'm going to mute my microphone so there's no background noise.
Cool. So I'm going to show you a little example. Let's let me make sure that my sound, I'm sharing my computer sound good, so you guys should be able to hear this. If you can't, let me know. But I'm going to show you a little example of the evolution of people, process, and products. So keep an eye on this and just see how things change in terms of people, process, and products that happen in this little video here.
Only 4 crew members, including the driver, are allowed to work on the car.
Brian, the audio isn't so good. I would stop the audio,
okay.
Brian.
Looks like the audio's bad.
Yeah, I would just
Okay. I'll turn off the audio here. I can kind of almost hear you. Sounds like that's not quite working. The audio, was that what I heard?
Brian, I think the video is not coming through either because it's supposed to be fast and it's just going frame by frame.
Okay, well, too bad. All right, I'm going to skip that part then. We'll get back to this. I can describe what it was. Can you guys hear me now?
Now it's perfect.
Okay. Yeah, that's something we didn't count on, I guess, is the video is streaming and anyway, new platforms. But what that video shows basically is something from 1956. It's a team of people. There's only 4 people in the car. It takes like a minute to refresh the car and get it racing. And this video shows takes about 2 seconds to exactly the same thing. And the metaphor there is that, there's a lot of things that are changing, and a lot of demands that you didn't have for,
Brian?
yeah.
It's Ron Gerber. It's your audio is a little choppy. This is the dangers of the coronavirus, and the fact that I haven't been able to migrate to Teams so quickly is, and we didn't have a chance to analyze this. And there's so much traffic on the internet, slowing down things. I don't know if you read that Netflix is no longer offers a lot of its videos in HD. Why don't you try it again? But if need be, Brian, are you dialing in through the computer or your phone?
Through the computer, but I just stopped my video, which might help.
Oh.
Sometimes that helps.
Yes.
Can you hear me better?
Yeah, this looks fine. I'll let you know if there's another issue.
All right. Yeah. So I stopped my video. I was broadcasting video of myself talking as well. And you guys don't need to see my face. I'll show the slides.
Okay.
So, all right. So, so basically the whole idea here is, enterprises, organizations are being asked to release things more often, and they're being asked to do it more reliably. And there's a larger amount of people who want to access your production code. It used to be acceptable that you could have a release every 6 months or a year. These days, that's really not acceptable. A weekly or daily is more the cadence that you have when you're talking about software releases. And there's a lot of people who want access to your data that didn't want access before. You could actually control it before. For example, you would have, just one database and one application that accesses that database. Now you probably have a website, you probably have a mobile app, you probably have some analytics and some logistics people who want to access it. So how do you actually manage multiple growing numbers of people who want to access your apps and access your data, and then combine it with multiple releases that are more frequent than they were before? And the answer is really DevOps. And that's why DevOps has been created. It didn't really come out of the blue. It's been developed over time, and DevOps is just a way of sort of formalizing those processes to deal with those kind of challenges. And this is a great quote from my colleague, Donovan Brown. DevOps is a union of people, process, and products to enable continuous delivery of value to your end users. And value is the other thing I would highlight in this sentence as well, because if you're not providing value, it takes a lot of effort and a lot of organizational change sometimes to set up a good DevOps organization. And if you're not really getting any value out of it, it's not worth working on. So let's talk about each one of those things. Before I do that, there is a group called the DevOps Research and Assessment Group, who's actually been purchased by Google. And every year around September, they produce this report, which is called Accelerate State of DevOps Report. And what they do is they interview a whole bunch of different operations who have high performance DevOps or something, or no DevOps, and then something in between. And they publish this report which describes what high performance DevOps teams can achieve. And just highlighting a few things in this report, they have 208 times more frequent deployments if you're a high performance DevOps team. And that probably scares the heck out of a lot of people. How do you actually handle 208 times more deployments? So many more opportunities for things to go wrong. But if you notice down here on the left, they also have a 7 times lower change failure rate. And if something does go wrong, they have 2,604 times faster incident recovery, which is nice. And one of the things that gets overlooked on the top right here is 106 times faster commits to deploys. And that means that all of the things that are processed when you go from an initial commit of code to deploying that code can be really quick. And that gives you more time for analyzing the actual results of your efforts. In other words, when somebody asks for a feature and they expect a certain result for that feature, did that actually deliver? Did that change deliver the results you're expecting. You have more time to focus on things like that. Or what should we be doing for our users that could bring more value? That's the sort of thing that you can focus on if the mundane, repetitive activities of DevOps are taken out of the equation by a good system. So what is a good system? A good system is actually people, process, and products. So people is the first part of this equation that has to be addressed. If you have a typical dev and ops team separation where the dev team is throwing code over the wall to the ops team and saying, hey, it works on my machine, make sure it works on the cloud or wherever you're deploying to. And the ops team is saying, hey, some of the things that you've given us, we're having to compensate a lot over here on our production systems to make them work the way they work, the way they're expected to work. And that's, what you need is you need a good system that will allow the dev and ops team to work together, have a clear-cut division of labor, and allow them to collaborate and communicate with each other. Here's a typical software development lifecycle. Plan, develop, release, monitor, and learn. The process has to be able to manage this. So the process has to be able to track a feature request through the planning phase, through the development test phase, through releases. And the one thing that is often overlooked is monitor and learn. So monitor and learn is really important as well in terms of just making sure, as I mentioned before, that the actual feature that was in part of the planning stage has developed the results expected when it actually gets into production. So products, people, process, and products. The products have to support the people and the processes. And you want to basically have tools that will allow each person on the team to fulfill their role easily while minimizing errors. So for Microsoft, we have GitHub, and Sasha is going to talk about GitHub's capabilities in the next session. We also have Visual Studio and Visual Studio Code. I'm going to show a little demo with Visual Studio Code, which is a free open source text editor. You can find it on GitHub. You can download it for free, and there's tons of extensions you can work with. For delivery, we have Azure DevOps, which is what I'm going to show today a little bit. We also have GitHub Extensions and GitHub Actions. Actions is something that Sasha will cover. I'm going to talk a little bit about extensions. And then we have operations. So as I mentioned before, monitor and learn is really the part that gets overlooked in the whole process when you don't have a good DevOps system in place. For us, we have Azure Monitor, which is a way of keeping track of your applications and your infrastructure. We also have a way of setting up governance through Azure Policy and Azure Automation. And the Azure Security Center is a great facility as well for developers and operations teams. We spend $1 billion a year on security. We have 3,500 people on staff who deal exclusively with cloud security. And we actually deal with trillions, literally trillions of threats daily that come in through our cloud. And we protect our customers there. So talking a little bit about Azure DevOps, there's several pieces here. Azure boards. Our Kanban boards, they're a great way to keep track of things. So I mentioned before, process, you have to have something that supports your process. And Azure boards are great because you can create tasks in the planning stage, you can assign those tasks, and you can follow those tasks through release and monitor and learn as well. Azure repos, every time I present Azure repos, it gets a little more tricky because so everyone's familiar with GitHub and GitHub repos. We also have Azure repos, which have been around for a while. The advantage, I often get asked, when would I use one versus the other? Why do we have Azure repos when we have GitHub? Microsoft purchased GitHub a while ago, in case you weren't aware. But there are some times when you want to use Azure repos. For example, Azure repos are really, really nicely integrated with your subscription. So you can manage who has access to your code. If someone is added to the team or leaves the team, you can easily set them up and manage all that right through your identity management system, which is built into Azure. And I'll show a little example of that later for approvals. The other reason why you might want to use it is we have TFVC support, Team Foundation version control. So if you're using Team Foundation Server and Team Foundation version control, TFVC is built into Azure repos. Otherwise, GitHub and Azure repos have pretty much parity when it comes to features, besides those things. All right, so what we're going to focus on today, though, is actually Azure Pipelines. So we're going to talk about Azure Pipelines. Azure Pipelines are build and release pipelines. I'll show an example of how they work. Azure Artifacts are a way of managing packages, dependencies that you use in common package management tools like NPM or Maven. And it allows you to create artifacts and share them and archive them for auditing purposes and things like that. Also, Azure Test Plans. So Azure Test Plans are a way to run tests on websites, to run load tests on systems as well. And it's an easy way to create them and integrate them with your whole DevOps process. So once again, just keeping track of all these different things. GitHub, and Sasha's going to cover a lot more about GitHub and the other in the next session, but I just want to mention a couple things because it's worth mentioning at this point. So GitHub Actions are great for automating. They actually have some pretty good CI/CD tools now. GitHub Extensions are third-party extensions that are created by all the cloud providers and others that allow you to integrate with local machines, with clouds, other things. They also integrate with popular IDEs and free private repos available through GitHub. Most recently, they're mentioned for Teams as well. So you get free private repos for Teams, which used to cost money. All right, so I mentioned before, I'm going to talk a lot about, well, not a lot, but I'm going to highlight Azure extensions, GitHub extensions today. And these are, as I mentioned before, AWS creates extensions. Microsoft has created some extensions, which I'm going to demo today. And other, Google and other cloud providers actually have their own extensions as well. So these are third-party additions to GitHub that allow you to do things that you wouldn't be able to do with the core GitHub product. And I'll show an example of that in a bit. So I mentioned DevOps. Being able to manage people, process, and people and process using products. So here's how we're breaking things down at this fictitious company that I've got. I'm going to show a demo for today, which is called Tailwind Traders. The dev team provides code, as you would expect. They provide unit testing sometimes. They provide GitHub repo, which actually stores the code and keeps track of the versions. And they actually help with CI/CD automation. There's some YAML files and things you need to update in Azure DevOps, and they actually help with that. The ops team brings to the table Azure DevOps project. So the dev team says, hey, we want to do some testing and release of our products. What can we do? The ops team says, we'll set up a DevOps project for you. They actually provide the web servers as well. They provide scaling. And they help with CI/CD automation as well. And then on top of that, the ops team also provides monitoring and security. So let's run through a little scenario here. Here's the, I just want to make sure you can see my screen. Can everyone see my portal screen right now? I just want to make sure.
Yes, the mode 50.
Yeah. Great. Okay, cool. Thank you. Just want to make sure of that. So what we've got here, here's the Tailwind Traders website. It's basically an e-commerce website. You can log in, you can create things. And right now we have free shipping. It's $100. If you buy $100 or more, you get free shipping. So the team has been analyzing this, and they're decided that because we ship a lot of large items, we're losing money on shipping. So they want to up that price. They want to up it to $500 and see what happens to sales. And they take this to the ops team and the dev team, and the dev team says, hey, what we can do is we can do this thing called A/B testing, where you can have half the people who come to the website see the $100 shipping cost, and half the people who come to the website seeing the $500 shipping cost that you want to raise it to. And we'll see if that affects sales. We'll see if the people who come in and see $500 don't buy things when the people who see $100 do. And anyway, so great, let's set up that scenario. So that's what we're actually going to do today. So getting back to Tailwind Traders, what we've got here, this is my portal. And inside the portal, I've got a bunch of resources here. This application actually has a lot of things under the hood. It's got a Cosmos DB database, it's got a SQL Server database, it's got some containers, it's written in Node, it's got a little bit of Java in it, and it's got some C#. So it's a little complicated application, and it runs on these web apps down here, which are the staging and the production web apps. So just setting the scene a little bit. So what we want to do, the first thing we want to do is we actually want to change that code. So let's go into our code here. So right here, you can see where the display is for the $100 or more orders. Let's just change that to $500. So right now I'm in Visual Studio Code. This is on my local machine. And I've got an extension. I mentioned before, there's tons of extensions you can use. I've got an extension here called GitHub Pull Requests. I've installed that on my Visual Studio Code. And whenever I make a change here, it checks against my repo on GitHub and tells me if there's any changes that need to be posted to push to GitHub. In this case, there's one because I just changed this file. There it is there. So I can stage it. I don't need to know anything about GitHub commands from the command line. I can just say stage this change, and then I can say angel beat APR 30. So what this does is it just sends a comment to GitHub, and I can just commit right here. Once again, I don't need to know the commands. This is a nice little feature too. Sync actually pushes and pulls. So if there's anything on my repo that was missed, it'll actually push and pull to my repo. So we just made that $500 change for 100. All right, there we go. So it's been pushed to GitHub. If I look at my GitHub repo, I had 259 commits. Now I got 260. Great. All right. So that's the one that was committed 30 seconds ago. Okay. So now we go into my DevOps project. Here's my project. And these are the things I was talking about before: boards, repos, pipelines, test plans, artifacts. We've got this new thing called compliance, which I'll talk about later if there's time. Okay. So let's go into our pipelines. And you'll see that just a second ago, 6 seconds ago, or sorry, it's running for 6 seconds. Just now, we had a trigger. So the trigger of the build has actually started. So this is Azure DevOps. I changed something on my local machine. I push it to GitHub and we go to Azure DevOps. So how did that actually happen? So while that's running, because it takes a while to run. So what I'm going to do is I'm going to go through a few other things while that bakes. It takes about 8 minutes usually to bake. So while that's cooking, I'm actually going to go through a couple of things. So I connected, this is a little video I'm showing now. I actually connected, and boy, I hope it works. Let me know if it's not working, Ron. What I did is I connected my GitHub repo with Azure DevOps using this extension called Azure Pipelines. So I was able to configure access. I already downloaded the extension. So as I mentioned before, extensions are written by third parties. They're not written by GitHub. They're written by, in this case, Microsoft. And what this does is it connects my repo. So we're still in GitHub. Now we're actually connecting to Azure DevOps. And we're going to log into my subscription at Azure DevOps. So what we need to do in this part to configure the extension is we need to tell GitHub where to connect. In this case, we're connecting to an organization in Azure DevOps called bbens MS, and we're connecting to a project called bbens Tailwind. And the idea here, as I mentioned before, the division of labor is very clear. So the ops team has actually provided this project for me to work with. It automatically guesses what my code could be. It looks at the code in that repo and it tries to decide what it is. And because I mentioned before, it's got a lot of different things. So it actually generated a YAML file based on, in this case, .NET Core that I can use. However, the ops team has provided me with a YAML file that they want me to use that meets their minimum compliance requirements for this particular application. So once again, this is the ops and dev team working with each other. So what I do is I actually paste that YAML file into my DevOps build pipeline. And I can create a new branch, or in this case, it's a demo, so I'm just committing to the master branch, which is generally not a good idea, but it's a demo. So what it does is actually creates the pipeline, and it does a build and a test for me. And now we have the connection set up between GitHub and Azure DevOps. So anytime there's a change, anytime there's a push, a commit to Azure DevOps, it's going to trigger a job for me. And let's actually go to the live job now. So that was a video. I'm going to show you the live job now. So there it is. So if I click here on the job, it's still running, build job, blah, blah, blah. It's running for 3 minutes. So where are we here? Okay, great. So we're halfway through what we need to do for that. And as you can see here, each stage is logged. So you get nice logs for each stage in case something goes wrong. Nothing ever goes wrong with my code, so that's not a problem. Anyway, and what's going to happen is when this actually gets to the done, it's going to check out the code, and it's actually going to trigger a release. And that release I'll explain now. All right, so while that's running, here's the releases. So this is the release I just did earlier today to test this out, make sure everything's working. It's good to do that before a demo. And let's edit the current release pipeline that we have. So you see we got a nice graphical interface. If you love YAML, if you have a passion for YAML, there actually is a way to create this with a YAML file as well. I like having this nice graphical interface though. The advantage of the YAML part is it's repeatable. You can cut and paste it. This is repeatable too, by the way. You can copy it and all kinds of other things. But basically what's going to happen here is whenever that build process is going to create a artifact. And I'm going to get the latest artifact from the build process that I specify here. And this little continuous deployment trigger is going to tell me automatically do this. I can also change this so it was manual as well. And you can also have a pull request trigger that goes straight from GitHub. All right, so that's the artifact. So this is actually watching for that build to complete. And when that build completes, it's going to do a release process. And here's the release process. So we go from staging, we go to something called Canary, and then we go to production. And I'll explain what each one of these things is. So basically, if you recall, we're doing an A/B test here, and that's where the Canary comes in. But let's start with staging. So staging here, I can go in and I can show you the task. Basically, it goes to an app service called bbens Tailwind Staging. And this is the app service here. It's got my subscription, and I literally just pick these from drop downs that come. And once again, so this is the ops team and the dev team working together. The ops team has already provided me with my staging server and my production server, and then set it up for A/B testing using Canary. So let's go to the production server. It's very similar to the staging server, except it's just called bbens Tailwind Production. All right. So it gets a little more tricky when you go to Canary. So Canary is where we're going to do our A/B testing. And what happens here, if I click on this task, you'll see I've got a checkbox here for deploy to slot or app service environment. In that case, we're going to use this slot called Canary. Don't worry if you don't know what slots are. I'm going to talk about that in a second. So that's our pipeline. It goes from staging, it goes to this thing called Canary, and then it goes to production. But that's not good. If we just have an automatic code that's being produced, how do you actually stop it from going straight into production? You want it to go into Canary and do this A/B testing thing. We have approvals for that. So you have post-deployment conditions. The post-deployment condition means that when this stage is complete, send an approval, and you send an approval to me. I mentioned before, one of the nice things about Azure DevOps and in the context of repos and also releases is this is all integrated with my identity management system that I already have built in. So I didn't need to do anything to register myself as the person to approve this. I just needed to type my name and it went out and found my information, and it will actually send me an email or a push notification and tell me, you know, there's something waiting for my approval on Azure. All right. And then we've got something here called pre-deployment conditions. So why do we have post-deployment and pre-deployment? Because sometimes the developer team will say, all right, we're done with this particular task and we're just going to fire it off to production. But the production team doesn't want to deploy this until Friday night, because they're not developers and they know that you don't deploy anything on Friday night. But anyway, they can specify different things here about at runtime when they actually want this to be deployed. There's also these things called gates, and gates are automated ways to actually choose what gets deployed without actually having to have a human intercept the process. We have policy compliance, so you can do some governance. You can invoke an Azure function, which Arshan just showed a little while ago. You can invoke a REST API, which most of the popular tools for like checking your source code for vulnerable open source packages use a REST API, so you can go out and you can get a yay or nay from your third-party source compliance tools. And they've got query Azure monitor alerts and query work items. So you can do other things basically to set up automated configuration and approvals as well. But in this case, we're just doing a pre-deployment approval using a manual task. All right, so I bet by now this is actually done. And by the way, don't forget deployment slots, just bookmark that. I'm gonna get back to that and I'm gonna explain how the A/B test works in a second. All right, let's go to our releases. It should be there now. Yep. So what's happened now is the build is finished. So if we go to our pipelines up here, you can see that the build completed. There it is, right there. If I go into it, it basically gives me a couple of warnings, which I don't care about as long as it compiled and ran. I don't, because I'm a developer. All right. And there's the build job. So it tells you everything worked. It tells you the stats on these particular jobs. Today it took 7 minutes, 39 seconds, which I mentioned before. It takes usually about 8 minutes. So that's good. All right, back to releases. So this release is happening using that format that I just showed you. So continuous deployment, it automatically found a new release and triggered this release. It went to staging. So now I can see this in staging. I can look in the logs and I can see the app service. So let's click on the app service here. There it is. No, sorry, that's the Kudu, totally different topic. All right, so there we go. So now we've got free shipping for $500 or more on orders. Great. All right, so but that's only in staging. That's not in production. Production is still $100 or more. So now A/B testing. How do we actually set that up? All right. Make that. That's the, okay, hang on a second. What's going on here? All right, back here. So how do we actually set up the A/B testing? And that's done through the web app. So if I go into the production web app here, let's go in there. All right, so the production web app, there's this thing down here called, where is it now? It moves once in a while. Deployment slots, there we are. So deployment slots, what I've done is I've set up something called a deployment slot. You can add a few of these. I believe 4 is the limit these days. But production is always BBenz Tailwind production. And then we have another one called BBenz Tailwind Canary. And that will take 50% of the traffic. So this is the way you do A/B testing. This is the way you do blue-green deployments. You can manually adjust this. So right now, half the people are going to go to production. Half the people are going to go to the Canary deployment slot. And the Canary deployment slot, if you look at the release, here we go. Here it is. Nope. I'm getting the release itself. Releases. All right. So this is actually sitting at Canary, and it's waiting for production to go. So it needs me to approve it, which I'm not going to do right now. What I want to do is I want to look at the log. And down here, the log, you'll see that it goes to bbenz tailwind production dash Canary instead of, yeah, and it shows the $500. So we actually have an A/B test in place. So half the people will see this. They won't see this URL. They won't see dash Canary in their URL. They'll just see bbenz tailwind production.azurewebsites.net. But they will see the different change in the shipping price. So the idea here is you can then change that. Now, let's go over here, because that release actually went a little faster than I thought it would, which is good. So I'm going to flip through this real quick, and I'm going to get back to it. Just ignore what you see here. There we go. Oh no, where's my URL? I hit it, didn't I? All right. Let's see. Sorry, I'm going to go behind the scenes here. I think that URL was hidden. There it is. We have enough time to do this, so I don't want to hide this slide. So if you guys now, if you actually go to this URL, aka.ms/mod50 site and or hit this QR code, now half of you should see the $500 shipping cost and half of you should see the $100 shipping cost. So I'll leave that up for a second and I'll let you guys go ahead and check that out. Now, inside of the Zoom client, there is a way to raise your hand. I don't know if you've covered this yet, Ron, but in Windows and Mac, you can do Alt-Y in Windows and Option-Y in the keyboard just to show your hand, because you're probably wondering, okay, well, how are you going to know if I see it? And in the other clients, there should be a raise hand button here. So you guys want to go ahead and do that. And then I'm going to check out participants and see what you guys found. So just do this raise hand if you see the $100 website. And then, okay, so yeah, cool. So 5, 6 of you, this is optional. Not everyone has to do it, but thank you for those who do. Cool. And then if you could just unraise your hand through the same method, through the Control-Y or Command-Y. Okay, cool. All right, so how many of you saw the $500 shipping cost? There we go. So a little bit more saw the $500 than the other one, but yeah, that's just, it's not a statistical thing. So cool. All right, thanks. Well, that worked. So the other things I want to show you as well, let me get back down to that. So some of the other things that I want to talk to you about, you can actually keep your investments. There's a little bit out of order there, but just in case you're wondering if we have more than Azure DevOps, yes, we do. So the idea here is, this is the software development lifecycle again. The plan and track, development and test, release and monitor and learn phases are covered. These are partners that we work with. All of these partners, if you're not using Azure DevOps, you're probably using some of their tools already. And we work closely with all of these vendors and third-party projects to make sure that our applications, not just Azure DevOps, but other applications and GitHub will work together with these. So that if you're invested a lot, for example, in Jenkins, don't worry about losing your investment if you work with Azure DevOps. We've actually been working with Jenkins Jenkins, we've produced a couple of different things. Let me show you something interesting here. So this is Jenkins, ci.jenkins.io. Everyone can visit this website anytime. It's a public website, and this is where Jenkins builds Jenkins. And they actually have a number of resources on the left here that are building different things. So when Jenkins gets a pull request, they go into this site, and there's tests that are run on those pull requests before they're used as a candidate for the next release. And as you can see here, some of these are running Ubuntu on EC2, that's AWS. And down here, there's a number of them running Ubuntu VMs on Azure. So just for those of you who don't know, Azure actually helps build Jenkins. We have infrastructure that we provide to the Jenkins organization, and they use it for Windows testing, for Ubuntu testing, and then there's this thing called ACI, which is basically Azure Container Instances. It's a Kubernetes cluster where you can grab a pod and test things. So they're testing containers here, like this one right here is literally happening right now. And this is always different no matter when you look at it. But here's the build queue. They run the builds. They try it against different platforms, different clouds, different versions of Ubuntu and other operating systems, including Windows. Here's a couple of Windows tests happening right now. So that's kind of cool. And as part of that partnership, we've built some references. You can get a reference for Jenkins on VMs, how you actually build your VM infrastructure, which is the same one they use for testing. We also have Jenkins on containers. And that's another reference architecture you can use. And there's actually these things called ARM templates that you can use to generate the environment that you see here. That's another useful tool for the DevOps organizations out there. We also have CI, CD tools built into our CLIs and a few other things. The Jenkins plugins are very useful as well. Microsoft maintains a bunch of plugins in cooperation with Jenkins that allow you to do things like, for example, if you have a build, you've invested a lot of time in build and test in Jenkins, you can run your releases in Azure through a plugin that connects directly to your release process. So I showed a GitHub repo using Azure DevOps build pipeline. Instead of the build pipeline, you can use Jenkins to do your build and then pass it to a release pipeline in Azure DevOps. All right, so we covered what is DevOps. Oh, one thing I didn't do, just a moment here. I didn't demo.
Brian,
Yeah.
I would try and summarize now so we can make sure we do that. One thing, one specific question you can answer is on how DevOps relates strategically or tactically with DevSecOps. And if you could also go to the Q&A, we're not going to get a chance to it, but maybe you could respond to how Azure integrates with a Jira or version 1. And you could see that in the Q&A if you could respond back to that, but at least talk about DevSecOps before we finish up.
Yeah, so DevSecOps, I touched on security a little bit, but all of the applications that we use here, when it's hosted on Microsoft, we have a lot of investment in security. We have a lot of investment in, in our security center, which manages any kind of threats that you have for hosted environments on Azure. When you do that build, for example, the build is actually using virtual machines on Azure, and those are protected by the security center. But specifically about DevSecOps, the topic is usually leading into compliance and governance. And we do have this new compliance and governance part of DevOps. And in general, Microsoft has a bunch of tools for governance. If you go to, oh gosh, what's the short link? I'll send a short link afterwards, but there's a link you can find which talks all about our compliance and governance offerings. And so it's not just general security, it's a way for you to implement your policies inside of Azure. For example, if somebody's created a VM, you can make sure that it has a minimum standard in terms of operating system and packages that are running on it so it's secure in your environment. things like that are built into Azure. We also have monitoring tools, something called Azure Advisor, which allows you to do things like making sure that that new VM you created actually doesn't have any glaring vulnerabilities that we've already discovered. You will be advised of that kind of thing automatically when you create a new resource in Azure. We also have things like Azure Health Monitor, which tells you if our own Azure services have any vulnerabilities or problems that we're having, and several other tools. I'll send them the links in the questions though. But what I did just now, if anyone saw there, I just approved these things into production. So now this is in production, and if I go into the production site, you'll see Tailwind Traders should be at $500 now. There you go. So that's in production. So just updated it. So the idea was that, you know, the team liked the $500 results and they moved it to 500. So I've got some docs alerts. These will be shared in the slides that are shared with this presentation as well. The DevOps Resource Center and the DevOps docs are there. We also have a feature called MS Learn, which takes you through a whole bunch of different DevOps topics. And here's some links for the session. Please do follow me on Twitter.